And we'll see how much of this you guys remember from Math 3, because you should have learned about inverses in Math 3, but I'm not sure how much you remember. So in the instructions, they would tell you to find the inverse. And I'm just going to give you a function. So f of x is 3 log base 2 of x. And when you find an inverse of something, the first step is super important. Does anyone remember what the word inverse means? We've talked about it a little bit. Opposite, they undo each other. So adding and subtracting are inverses, multiplying and dividing are inverses, squaring and square rooting are inverses, and then we learned in this unit that exponentials and logarithms, those are inverses of each other. So if you want to undo something raised to the x power, then you would do log base, whatever the base is of that something raised to the x power is, if you want to get to that. So when you find the inverse of a function, anyone remember what the first step is? It's trading something. You trade the x and the y. To find the inverse of something, you trade the x and the y. So in this equation, the y is the f of x. F of x is just another name for y. It's just what we name different functions so that we can tell them apart. So we have like f of x, g of x, h of x, m of x, all different names so that we don't get them confused. So to find the inverse of this function, the very first thing we would do is trade the x and the y. And then to undo each operation, you would solve for y, because as you're solving for y, you're going to be undoing each step. And what I usually tell students is to do order of operations backwards, because if you do it backwards, then you're going to be undoing each step in the reverse order. So order of operations is, please excuse my dear Aunt Sally, if you guys remember that. So we're going to do that backwards. So the first step is going to be to look to see if you can add or subtract anything to the other side. The second step is going to be to look to see if you can multiply or divide anything to the other side. And with this, your goal is always to move stuff away from the variable that you're solving for, which in this case is the y value. So add or subtract first, multiply or divide second. Third step is the exponents. So to either introduce an exponent or to get rid of something, to reveal an exponent, something like that. And then last step is parentheses, and it's not necessarily parentheses specifically, but it's grouping symbols. So it could be parentheses, but it could also be like the actual square root sign, which is keeping something grouped. It could be like the bottom of a fraction, which is keeping something grouped. So P doesn't necessarily always mean parentheses. Okay, so in this problem, there is nothing we could add or subtract to move it away from y. There's no plus or minus sign, so we're going to skip that step. Is there something we could multiply or divide from the right side over to the left side? The 3. We can divide by 3. So x divided by 3 is log base 2 of y. Okay, is there anything in the problem we could do that has to do with exponents? The base 2. We have a log base 2 we want to get rid of to help get the y alone. And if we put a base of 2 on each of these problems and make this an exponent, then that would get rid of the log base 2. So I'm going to put a base of 2 on the left side and a base of 2 on the right side. And then that's going to make those two things cancel. And then the y is going to be all by itself. So we have a base of 2 to the x over 3 equals y. All right, so we got our y alone. At this point, we're going to say this is our inverse function. And so at this point, we look back at the original notation and we write it as inverse notation. So if this is f of x, then I'm going to say f inverse of x is my final answer, 2 to the x over 3. And this is what I say the answer of the problem is. Okay, let's try another one. So let's say I had log base 1/3 of 2x plus 1 equals g of x. So g of x is just another name for y. All right, so what is my first step? Before that, trade the x and y. Okay, so I'm going to say log base 1/3 of 2y plus 1 equals x. All right, and then what should I do? I should subtract the 1, so I'm going to go ahead and write out the steps. So we've got adding and subtracting, multiplying and dividing, exponents, parentheses. Okay, so very first thing we're going to do is we're going to subtract the 1 over. So we've got x minus 1, and then over here we've got log with a base of 1/3 of 2y. Okay. Next step, is there anything we could multiply or divide to get it away from the y? The 2 eventually, but right now that 2 is protected by grouping symbols. We got parentheses around it, so we can't get to the 2 quite yet because that's down at step 4. Okay, so we're going to stop with that. We're going to move on to the next step with this exponential part. So is there an exponent I can put in the problem? Yeah, I'm going to put a base of 1/3. I'm going to introduce a base of 1/3 and turn this into an exponential problem. So base of 1/3 and the log base 1/3 are going to cancel each other out. So at this point, I've got 2y equals 1/3 to the exponent x minus 1. So at this point, I've gotten to my grouping symbols, my parentheses, and now I go back up to the beginning and I walk myself through the steps again. So now at the beginning, there's nothing that can be added or subtracted, and now I'm back to the multiply divide step. So what do I do to get the y alone? Divide by 2. Now, for the final answer, there's 2 ways you can write that depending on what your comfort is. You can write it like this. You could say 1/3 to the x minus 1 over 2, but most of us probably think that that looks kind of clunky. So if you don't like the divide by 2 written like that, you could think of this as a coefficient of 1/2. That if you have something divided by 2, it's the same thing as taking 1/2 of something. So you could put a 1/2 in the front and then have 1/3 to the x minus 1. So you could have the whole thing divided by 2, or you could put a 1/2 in the front. Both of those are the same thing. So now we go back to the beginning. We say the original notation was that this was g of x. So I'm going to write g inverse of x. And I'm either going to say 1/2 times 1/3 to the x minus 1, or I'm going to say 1/3 to the x minus 1, all divided by 2. Both of those are equally correct. So whichever one you prefer is totally fine. All right, let's try this one. Let's say we had ln x minus 3 minus 4. So here's my y, and what is my first step? Switch the x and y, so I'm going to say x equals ln of y minus 3 minus 4, okay? And then what should we do? Add the 4. So x plus 4 equals ln of y minus 3. Okay, so we did the add subtract step. Then what should we do? Yeah, there's nothing to multiply or divide, so we're going to go straight to putting a base and turning this into an exponential problem. So ln is the same as having log with a base of e. So if you want to get rid of a log with a base of e, then you have to do a base of e on each side. So our base of e is going to cancel out with the log base e. And we're going to have e to the x plus 4 equals y minus 3. So e to the x plus 4 equals y minus 3. And at this point, we got inside our grouping symbols. And now what do we do? Add the 3. And do I add the 3 to the 4 and say x plus 7? No. What do I do? So e, keep the x plus 4 in the exponent, plus 3 on the end. Okay. Now I have the y here, but the problem really is going to be h inverse of x because that was the original notation. So h inverse of x is e to the x plus 4 plus 3. Okay. How do you guys feel about those so far? Are you comfortable with those? Yeah? Okay. Let's try some exponential problems. So let's say we've got k of x is 2 times 10 to the x minus 5. 2 times 10 to the x minus 5. So k of x is our y. What is our first step? Switch the x and y. X equals 2 times 10 to the y minus 5. Okay, so first we have to see if there's something we could add or subtract to the other side to get it away from the y. We're going to add the 5. Okay. So x plus 5 equals 2 times 10 to the y. Is there something we could multiply or divide to the other side? The 2. So what do we do with the 2? Divide by 2. So again, with the 2, you have two options. You can write it like a fraction. And you can have x plus 5 divided by 2 as a fraction, or if you want to put a 1/2 in the front, you could write 1/2 and then put x plus 5 in parentheses. It's totally up to you. Both of those are equally accurate. Okay, so now we're on step 3, which deals with exponents. So now we want to reveal the exponent by getting rid of the base of the exponent. And how do we get rid of the base of an exponent? We do a log with the same base. So I'm going to do log base 10. And does anyone remember what is special about log base 10? It's just log. Yeah, we don't actually have to write the base of 10. We can just write the word log because this is the common logarithm. So log base 10 of x plus 5 over 2, or you can just write log of x plus 5 over 2, since this is the common logarithm. You don't need the base of 10. All right, and then the original problem was k of x, so we're going to write our answer here as k inverse of x, and then that's log of x plus 5 over 2. If it makes you uncomfortable that you're doing all this stuff and you don't know what stuff you're taking the log of and what stuff happened after, you can put parentheses around this to just say it's log of this stuff. You technically don't need it because a fraction is considered to be like one whole thing, but it's not a problem if you put the parentheses there. Okay, let's try an E problem, and then I think we'll be ready for the practice assignment. So let's do y equals e to the x minus 3 plus 2. Okay, so what do we do? Trade the x and y. So x equals e to the y minus 3 plus 2, okay? And what do we do next? Subtract the 2. So x minus 2 equals e to the y minus 3. And then what do? We ln. Yep. So the next thing we need to do, we can't multiply or divide anything, so we have to get rid of the base of e. So we're going to log base e each side, which is what the ln is. So log base e, log base e. And since I've got two things, I'm actually going to write x minus 2. All right, and then what's our final step for getting the y alone? Add the 3, yeah. And do you add the 3 to the negative 2? No, because the negative 2 is protected by those grouping symbols, right? X minus 2 is protected. So we're going to say ln of x minus 2 plus 3 happened later equals y. And in this particular problem, the original function was called y equals. And so here we don't have to rewrite the whole thing. We can just put y inverse for the final answer, and we're done. Okay. That makes sense for everyone? All right. This is one of my favorite assignments that I do for all my classes. So I'm going to show it to you so you guys can understand how it works. This is a Build-A-Monster assignment. So When you look at problem number 1, you are not doing 5 different problems. You are doing one problem with multiple choice answers. Okay? So the first page has the problems you are doing. The second page has the monster you are drawing. No? No? Oh, that's fine. Okay. So problem number 1 tells you what type of feet you're going to draw. So you're going to look at the first problem, you're going to find the inverse of the first problem, and then you have 4 multiple choice answers. Once you pick your multiple choice answer, you will draw the feet that correspond to that answer. Does that make sense? Then you'll do the next problem, you will solve it all out, you will find the multiple choice answer that is correct for that particular problem. That will tell you which hair to draw. So when you guys are done, in theory, if you've gotten every single problem correct, all of you will have the same drawing. But it will look different because you guys are all different, and your drawing skills are all different and all of that. And it's very entertaining to see everybody's drawings. This is like my favorite thing. It's so fun. So a couple of these do have color options. So when you guys get to the point where you have to start coloring stuff, there's colored pencils, markers in the back for you guys. Do you have to do the picture? Absolutely yes. There are only 8 problems for you to do. So you do have plenty of time to do the math and the coloring. All right? Sound good? We got it? Okay, so I'm going to pass these out. You guys are going to have a wonderful, relaxing time finding inverses and coloring. It's going to be a great time had by all. Sound good? Marvelous.